Hey, what's up, everyone? Today we are going to continue our discussion on the random forest. We are going to move on and to discuss another topic, which is feature importance. I'm pretty sure for some of the course projects, you may consider use the feature importance to better improve your model or just to reduce the training time. Okay, so today we are going to move on to a new dataset, and that is a bank marketing dataset. And they collected this dataset by just calling the people who opened the account in a specific bank and ask them what are the customer's informations, and then make an offer to the customer and decide whether this person is going to take the offer from the bank or not. Okay, so as you can see, the Y column, that is the target column we are going to make the predictions on. And you can see for each of the customer, we have the age and the job, marital status, education, etc. So we have some categorical columns for sure. Okay, so our question is, well, which features are important? And if we throw away some of the unimportant features, can we improve the performance? Okay, so we know, well, by just looking at the data, we can this is a classification problem because we are predicting labels, and I would guess the labels, there are only two values, yes or no, right? And this data is not that perfect. There are many categorical features, and there is a day, there is a month. So how do we do with those categorical features? So the first thing I would like to try is I put all the categorical features, the column names, into a list. And after that, I create a iteration to iterate each of the categorical features and take a look simply to see how many distinct values are there. Okay, so well, it's not a surprise for the months, and we have probably 12 distinct values. Okay, and another one is for the job. We do have a lot of distinct values. Okay, so those are all the categorical features we are going to deal with. Okay, and to move on, well, the first thing is I want to do something different to the months column. And other than that, the remaining columns, I would say they are all categorical features, and I just want to do a one hot encoder. And pay attention to here. So for this column, and I guess that is loan, right? Loan, yes or no. Okay, this is just a binary feature. But when we send this column loan to the one hot encoder, which is here, and then we do, if we do the drop one, and then we only leave one feature. So this is probably the easiest way to cast a binary feature into a numerical feature with either 1 or 0. Okay, so I do the get dummies for all the categorical features defined here, and after that, okay, so you can see month is still a categorical feature, and the target class is now moved to the middle, but no worries, it doesn't need to be the end of the data frame. And the next thing, well, for the months, I'm arguing that for the January, February, I want to replace them with 1, 2, and 3. So why am I doing that? The reason is, well, I am arguing for the February, that is the next month of January. So February is January plus 1. So is that really meaningful or not? I'm not quite sure, to be honest. And especially, we have the month and we have the day, right? So is that the right thing to do or not? And you can argue with me, it may not be the right thing to do. Otherwise, if you're just treating January as a distinct feature and February as a distinct feature, and you don't want to emphasize that February is the next month to January, and then you may just do the one hot encoder as well. So, well, this is the part for the exercise. Okay, so the next part, I apply the mapping, and then I map all the months, all the columns in all the values in the months to a numerical value here, like this one, 5 for May. Okay, so now this data set is really ready, and we want to do the train test split, and then I do the random forest classifier. Okay, I want to pause here and ask you a question. Why I didn't do the standard scalar? Is that necessary or not? Think about that. The answer is no. It's not necessary at all in this case because we are doing the random forest, and this means we are creating a lot of decision trees. And on the decision tree model, we are not measuring the distances between two samples. Since we are not measuring the distances, and it doesn't matter if you want to do the standard scalar or not, so I'm going to leave the dataset as is. Okay, so we do the training, and then we do the prediction, and we got the accuracy score, and the accuracy is 90%. So, well, it seems that we should be reasonably happy with that. But remember, the topic today is feature importance. So after we have already built the decision trees in the random forest, in this case, we want to think about how we can get the important features. So think about that. When we are doing the decision trees, when we on each of the split, we do a greedy algorithm, right? So we find the split which can maximize the Gini difference between the root and the weighted Gini of the two children. So we are doing the greedy algorithm. This means if we do a lot of splits on one feature, this means that feature might be a good feature because when we are splitting on that feature, and then we have a big drop of the Gini, right? So having a lot of decision trees, and those decision trees, if we want to look into them and see what features they are doing the splits on, it may give us a reasonably good idea on what are good features. And guess what? Random forest can do that for us. Well, the easy thing we can do is if you do the random forest model dot feature importance, and it will give you the data. However, that's not so readable. So I decided that I want to put that information into, well, by the way, that's a series. Okay, I want to put that into a data frame. So I want to use the X-string columns as the indexes, and then for the only column I'm going to name that importance. And after making that into a data frame, the next part I want to make a sort on the importance, and then from the high to low. And remember, well, the higher the more important the feature is. Okay, so I put all the information into a data frame, and then I did a sort, and then you see the duration. Duration is the most important feature. Well, remember this data set was collected with the phone calls, right? So if you spend a lot of time talking to a banker and considering and discussing whether this offer is good for you or not, and probably, well, the longer you have this discussion, the more likely you are going to take this offer. So duration is one of the most important feature that makes sense. And then the balance, the age, well, they are all important features. And to my surprise, the day is also an important feature. This means on specific date of the month, and people are more likely to take the offer. Probably, I would guess that should be the end of the month. So at the end of month, and probably some of the people are struggling, waiting eagerly for their next paycheck, and at that time they may need a small loan. Well, I don't know, but that's my guess. Okay, so if you go down, okay, down here, the job. So job management, job technician, and job blue collar. What are they? They are the job column after we have done the one hot encoder, right? So there are a lot of distinct jobs. So for each of the job, we are going to make a distinct column like the job management, job technician. So management and technician, they're all distinct values in that job column. Okay, so it seems that for the job, well, the job, well, no matter what kind of the job they do, and the jobs are not that important. So that's my observation for this one. And well, I'm gonna pause here because this video is more than 10 minutes now, and I will see you guys in the next video. Bye.